Okay, hello, and welcome back. Um, Today's lesson is going to be a continuation of what we did in the last video, but we're going to be introducing the idea of an extraneous solution. So let's start off with reviewing a little bit of what we did last. We are going to be solving for x for these solutions. So last video, I introduced the idea of SAD-MERP. The new thing here was that P, where we introduced radicals, but it was still our order of operations. So we're going to look for any subtraction addition that we might have. And then from there, we're going to look for division multiplication. From there, we'll solve for any exponent or radical that we might have. And lastly, we will solve for the parenthesis. So consider this your warm-up. Go ahead and get started on these first two problems, please. Okay, for the first, you should have gotten x is equal to 14. You start off with division multiplication. You cancel out the 2's. And to eliminate the radical of our SAD-MERP, we raise it to the power of 2, and then we subtract 2 to both sides. So following the same order of operations, go ahead and solve the next one. Okay, so you should have gotten x is equal to 65. You start off by eliminating that minus 2. Now to get rid of the third root, you need to raise it to the power of 3 on both sides. That gives you 125. Add the 5 divided by 2, and you should get x is equal to 65. Okay, so before we get started with the new thing for today, we're going to hit some vocabulary. We're going to talk about an extraneous solution. So an extraneous solution is a solution or an answer that is not true. Now, I know that might not make sense right now, so we're just going to go ahead and jump into a problem and then come back to what that actually looks like. So let's go ahead and solve this. We're going to use the same idea of SAD-MERP. I'm going to write it here so that we don't forget what we're doing. Okay, so when I look at this, I recognize that I have this plus 1. Now, usually what we want to do is we want to move that plus 1 to the other side. Now, in this case, we have variables on both sides. So ultimately, we would want all the variables to be on one side of the equal sign. I am going to keep this here because I actually want to get this x a little more isolated. So I'm going to start off by getting rid of my radical. I can't do anything to this yet because it's stuck inside. So if I get rid of my radical, then it's kind of free game for me to move it wherever I want. So in order to get rid of this radical, I am going to raise both sides to the power of 2. Now on one side, I am left with 7x plus 15. And on the other side, I am left with x plus 1 squared. Now, a common mistake that I see here is that people want to say x squared plus 1. Now, I'm going to write this part in pencil because that's not right. What most people do is they want to take this 2 and they want to distribute it to each one, and they would say x squared plus 1 squared, which is 1. Now, I know you can barely see this, and that's intentional because I want to erase it, because that's wrong. We actually cannot distribute that negative sign. So I'm just going to go through and erase it so I can show you how to actually do it, because you know how to do that. I'm going to take that part off to the side over here so I have a little bit more room. And I am going to do x plus 1 squared. Well, I know squared means that there's 2 of them, right? So I'm going to go ahead and expand that. X plus 1, x plus 1. Now we can see this, and we notice that this is a multiplication of 2 binomials. So we know a few methods of how to solve for this. We can use FOIL, which I don't like, we can use distribution where you can split up the first one and multiply it by the second, which I know some of you guys prefer, or we can do the method that I like the most, which is our area model. I am going to solve using the area model, but if you prefer one of the other ones, you are free to use that if that's what you want. Okay, so x times x is x squared. 1 times x is 1x. 1x plus 1. I notice that I have my like terms right here, which gives me plus 2x. So I can say that this is equal to x squared plus 2x plus 1. So I took this part here, my x plus 1 squared. I did it over here so I can have the space for my work. I expanded it, which gave me x plus 1, used my area model, combining my like terms, and I got x squared plus 2x is equal to 1. But this is still equal to this, so what I'm going to do is I'm going to bring this over to this side here. X squared plus 2x plus 1. I just took this, did my work, and now I'm bringing it back. So now I have variables on both sides, but I'm free to move them because they're not closed by a radical or by parentheses or anything like that. So I'm going to go ahead and continue my work here. I am going to choose whichever direction I want to move things in, but since this x squared is my positive, I'm going to decide to move this to the other side. It's just easier when I have a positive x squared here. I'm going to subtract 7x and combine it with this, and then subtract the 15 and combine it with the 1. Remember that you want to line them up with their like terms. So here I am left with x squared. 2 minus 7 would give me minus 5x. 1 minus 15 is minus 14 is equal, this canceled and this canceled, to 0. Okay. Now this turns just into a factoring problem like we have done in the past. So I am going to take this and label my A, B, and C. A is 1, B is negative 5, and C is negative 14. A times C goes on top, so negative 14, negative 5. And I know that my two numbers here would be negative 7 and positive 2. Okay. I'm going to turn that into my area model. So I'm going to fill in the inside now. My first term is x squared. My last term is negative 14. Then I get a negative 7x and a plus 2x. Pull out my GCF. I get x, which leaves me with an x here, minus 7 plus 2. So I can rewrite this as x plus 2, x minus 7 is equal to 0. And I can solve. X plus 2 is equal to 0, and then x minus 7 is equal to 0. So x is equal to negative 2, and x is equal to a positive 7. This is just going back all the way to, I think it was chapter 3 when we did this. Now, from what we have seen in chapter 3, we would say that these two are my solutions. But we have to think back to our extraneous solutions, which means that we have an answer that might not be true. In order to know whether it's a true answer or not, I have to plug it back into my original equation. So I need to test my solutions. So I'm going to say x plus 1 is equal to radical 7x plus 15. And in this one, I'm going to plug in my negative 2. And then I'm going to write it again over here. X plus 1 is equal to the square root of 7x plus 15. And on this side, I'm going to test my x is equal to 7. So since they are x's, instead of this x, I am going to write negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15 over the square root. Okay, negative 2 plus 1 is negative 1. 7 times negative 2 is negative 14. Negative 14 plus 15 is the square root of 1. The square root of 1 is equal to 1. Does negative 1 equal 1? No. Therefore, x is equal to negative 2 is an extraneous solution, meaning it's not true because this statement right here is not true. Now we look at the next one. Instead of plugging in a negative 2, I'm now going to plug in the 7. So 7 plus 1 is equal to this would be 8. This is the square root of 49 plus 15. 49 plus 15 is 64. The square root of 64 is 8. Does 8 equal 8? Yes. So, x is equal to 7 is our only real solution. And our final answer. Okay, now looking at this, it looks pretty overwhelming. We are really bringing in every idea that we have learned so far to solve this one problem. We are looking at multiplication of binomials. We are looking at factoring. We're looking at the zero product property. Then we're looking at evaluating those solutions back into that original problem. So let's look at another one and break it down step by step for you to do. All right, so let's look at this one. You can see that it's pretty similar to the last one that we just did. So that's the one we just did. You can see that this one is pretty similar to it. So we should be able to do it just the same way. I want to start off by getting rid of that radical. And I do that by squaring both sides. That leaves me with 2x plus 7 on this side is equal to x minus 4 squared. All right, so now go ahead and multiply this out and give me your new equation. Okay, when you multiply that out, you should have gotten x squared minus 8x plus 16. What you want to do here at this point is start combining your like terms. To do that, I am going to subtract my 2x and my 7 to both sides. I am left with this. From this step, you want to factor. So go ahead and factor here. Okay, when you factor, you should have used your A, B, and C, your diamond, your area model, and have gotten x minus 1 and x minus 9. From here, you want to solve for those x's. So you want to use the zero product property first. And then I want you to test whether the points will be extraneous or not. So I'm asking you to finish and give me your final answer. So I used my zero product property and I got x is equal to 1 and x is equal to 9. I substituted those values in to test them. I saw that x is equal to 1 gave me x is equal to negative 3, which is not true. So that one would be extraneous, whereas on the other side, we get 5 is equal to 5, therefore x is equal to 9 is our only solution. The 5 doesn't mean that x is equal to 5. This is just proving that x is equal to 9 is true. Now, a common question I get at this part is, well, isn't this plus or minus 3? So wouldn't that mean that technically negative 3 is true? When it comes to these cases, and we'll see that when we're graphing, we are only taking the positive one from square roots. So we cannot look at the negative here. It is only the positive 3. That idea of the plus or minus symbols doesn't apply with these, and you'll see that once we start graphing. So let's look at another example. Hopefully you're getting the hang of it and see how we do. Okay, so you are going to work on this one on your own. Before I show you the final answer, which would be something like this, I will check in with you right at this point, right before where you factor. So work, and if you feel like you need to check in with me at some point, it will be at this point, and then we will jump to the end. So now I'm breaking this one problem up into just 2 steps where I check in with you. So go ahead and get started. Okay, so I want to check in with you guys. At this point, I am ready to factor. I got rid of my radical by squaring, multiplied off to the side, combined like terms, and now from here, I am ready to start factoring. So if you got to this part, go ahead and continue. If you didn't, you got something wrong, here is a good time to stop and check what you did wrong. Go ahead and finish up the problem. All right, and here is your final answer. You should have gotten x is equal to 3 and x is equal to 12. When you check them, you should have seen that x is equal to 12 is your only solution. Okay, and this is the last one that we are going to do. I'm going to have you do it from start to finish all on your own without me checking in with you. So please go ahead and get started. Okay, you will see that I didn't show all of my steps here. I got that x is equal to 25 was my only solution. You should be able to multiply this out using area models. We've been doing that for a few chapters, so I skipped that step and I went straight to its multiplied form. Then I did a little bit of work with factoring here, and then I wrote it down, solved for my 2 possible solutions, tested them, and I found my extraneous one, which was 4. So this one would not be an answer. And I found that x is equal to 25 is my only solution. This is what you will be doing in your assignment for today. Make sure that you have these notes copied down, and if you don't, you have the YouTube channel which you can rewatch this at. And that's all I got for you guys.